We're good.
Okay, so this is the model space. Okay, so this is where all of our drawings will be. This is the properties toolbar. This is customizable. Like you can either minimize it if, but I like to keep it open because it sometimes shows you things like the length of a curve or the area of a closed polygon. And then these are your individual other toolbars. So we will basically be working here a lot, and then we'll make our model in the model space. And then once the model is done, these down here, all of these tabs are to put the model in a drawing, in an engineering drawing. So you guys must have probably seen this on like architecture sheets and all. So those the final drawings we will put here, and then finally we will export them into PDF. Um, so well, um, yeah. So Adrian, can you
Yeah,
confirm if you see? I'll open this details or like the layers
yeah.
tab, and can
Okay.
you confirm you see all of these layers in your model or in your
Uh,
file?
I have, let's see, 1 second.
At least most of them.
Yeah, I think all of it's there. Yeah, I can see all of them. Starts
Okay,
with 0
perfect.
and there's like some 20 of them, I guess.
Nice. So these layers are somewhat important. Actually, we will use only like three or four of them, but these layers were basically done. I mean, these were a part of our template from before. We don't really use them that much anymore, but we do use three or four of them, and I'll let you guys know when exactly we are using which layer. Okay. And
Okay.
at any point, if I'm going too fast, then please let me know. And if you guys have any questions at any point, then definitely let me know. So I think Isaac wasn't here yesterday, so I'll just uh, sort of give an overview of the process. What we do is we take a picture of the or we take a Google Earth screen grab of the house that we want to work on, and then we import it into our model space, and then we first scale it, and then we start sort of tracing it on AutoCAD with the shapes and the lines. But before that, you need a couple of more things open in your to work from. So the first is the survey. So I've sent everyone the survey sheet. This is what it looks like actually. This is probably like it's a little tilted, but this is the most important page. So if you guys want to go ahead and open it, and or I think Adrian is the only one who's following along, right?
I'm following along.
Or
Why am I the only person who?
oh no, because I don't know. I mean, is Isak, are you also? Because I know Krishna doesn't have AutoCAD right now, but
I don't think Isaac
I
also
have,
has.
I haven't installed it yet. So
okay, okay. So Adrian, do you have it installed? And so could
Yeah,
you yeah, could you see if you find all of this? If you
I
can follow
have.
along, that's fine.
Yeah, yeah,
Otherwise, just keep like looking. Anyway, so this is what we work from. Okay, so
okay.
I'll actually just open this up in a different place so that it's handy for me. So if you guys notice over here in this lower right corner, there is already a orientation of the panels that we are going to put. So on this house, we are going to put these 8 panels in this location. So this is pretty set. So we don't really need to determine where to do that. It's already given from this site survey. This is generated by the by someone who sells the project. And another thing that is important is this. So here on the first page, there is the name of the module, and there is sometimes there are dimensions. But since this does not have dimensions, I will actually send you guys the dimensions of the modules. Just know that
Okay.
typically dimensions are 40 inch by 66 inch. You don't have to remember that right now, but that's generally like true for most of the panels. So what we are going to do is we're going to import an image from Google Earth and then make this a similar layout to this, and then define the layers and put these panels on. This layout is it's actually from this software called Aurora, and it is pretty indicative, but it's not that accurate. So that's why we want to make a more sort of high fidelity scaled model. So the first step is to go to Google Earth and look for the address over there. So the address for this property is 6546 Windward Ridgeway, San Diego, California. So then AutoCAD, Google Earth actually takes you to that property. So we right now have Google Earth Pro, so we can actually see all of the historic satellite images that Google Earth took. I think in the regular non-premium Google Earth, you can only see the latest one, but we have access to this historical imagery. So while selecting the image, the image of the rooftop, you have to be careful to not include skewed images. So skewed images basically mean images that are not taken exactly from the top, or at least approximately closely from the top. As you can see in this image, you can actually see the eastern wall of this house, right? So this means that this image was probably taken from a little bit east, and it was not perfectly above the house. So, and it happens pretty commonly. So this satellite image will actually potentially be taken from Texas. The satellites cameras are so good that they take these images from as far as Texas in California. That's almost like 2000 kilometers east. Anyway, so the kind of image that we want to select typically in San Diego was pictured in 2012. So November of 2012, the imagery was really good during that time. So you see, yeah, so these are all the historic images, but this is an image from November 2012. As you can see that you can't really notice the side walls of these homes anymore. These are all townhouses. You can only see the top roof. So this is one of the ideal characteristics of that. So once you select an image, and sometimes if you are not able to select an image, then I will happily provide the image for you. What you have to do is you have to take a screenshot of it. So, but before that, sometimes, like this is like misaligned or turned or whatever, or, sometimes Google Earth actually like takes us into that 3D view orientation. So once you press R here, it basically centers the image or flattens it, and it puts it into a north-south orientation. So as you can see, I can potentially like turn this image too, right? Sometimes we do that on Google Maps, but then you go anywhere and then you press R on your keyboard, and then it will again orient it to north. And same for this cube. So once you have this, to make this part go away, disappear, you click on history over here, and then quickly click back on the map. So I go history and map. So that it has now disappeared. And now we are kind of ready to take a screen grab. But before we take a screen grab, we need this thing to actually to scale this image. So to do that, what we do is we have this little scale symbol here on the top, if you guys can see here. We open the scale, and it pulls up a ruler, and then it pulls up this little cursor that looks like those crosshairs. And then towards the bottom of this image, we kind of zoom it out enough to at least have like 400 or to 500, around like 350 to 400 feet actually on the image. So I'll actually zoom it in a little more. So let's see. So see, this is at like 440 40.57 feet, right? You guys see it?
Yes.
Okay, so I click this, and then this basically keeps the line over there, and then I will go ahead and make a screenshot of it. So I think Windows has a default screen grabbing tool called Snip and Sketch. You can use that, that's fine. But make sure to include the entirety of the ruler on the left to kind of include the measurement. And make sure to also include like a large portion of it. And so what you have to do is you have to save this image in whatever format you want. Like AutoCAD is pretty versatile for formats, but you have to save it in the same place that you're going to make your store your AutoCAD model in. Okay, and then you have to name it with the customer's last name. So the customer's name is actually on the survey sheet, but right now I know the customer's name, so I'm just going to save it as that. And then write down GE after that. GE stands for Google Earth image, and save. So now this is done. Now you actually close out Google Earth and then go back into AutoCAD. So now we're going to import that image. So to import that image, we basically go to Insert, Attach, and then it pulls up the system dialog to attach things. You find that image where it was. So for me, it was in training layouts. And then basically you click OK, and then it shows up, and then it asks you to place that image somewhere. So you see here, it says specify insertion point. So insertion point should be around roughly here in this quadrant, in the site place. And then for now, you can make the image like roughly like, as long as these like 2 lines. And then we are going to, this next step is we are going to scale it. So I think I told you guys how to scale it yesterday, but I'll just repeat it again. So now we know that in AutoCAD, we are in feet. Okay, so our units of measurement are feet. So this entire model is in feet, but the feet that, okay, so but in this Google Earth image, the feet that are used here will probably be different because this image and the AutoCAD is not the same scale. So what we are going to do is we are going to measure what this length is in our AutoCAD model, and then divide that by this length that is in the Google Maps image, and that will become our scaling factor. Okay. So to do that, what we do is here on the top left corner, there is this line segment. Okay. And in AutoCAD, you can work in this mode called ortho mode. So in ortho mode, everything will be in 90 degrees. So the cursor will only move in 90 degree. Okay. So it will either move 90 degree to east or west, or 90 degrees, or it will directly move north or south. So what I do is I zoom in all the way, and you see where the pixel for this line actually starts. So you can basically, where the dark pixel starts, you can place your first starting point of the line there, and then drag this line all the way until the last pixel. So somewhere around here. Okay. So this is more than enough accuracy that we need. And then, so now you press enter, this line segment is created, right? So this is basically created over that image, right? Now what we are going to do is we're going to measure that line segment. Okay, so to do that, we basically go into this annotation toolbox. In annotation, there are different types of measurements that you take. I typically like to take linear. Actually, I forgot to specify one thing. When I actually took this line right on Google Maps, Google Earth, I made sure that the orientation of it was 90 degrees, because because pretty precisely the 90 degrees on the Google Earth is the same as the 90 degrees on AutoCAD. So then I don't have to potentially make like a, like correct for tilt, or sort of chase a line in a tilted plane. So I can just work in the ortho mode, and ortho mode is pretty simple to work in.
Though, just one question.
So yeah, go
How
ahead.
did you get the line to be 90 degrees in Google Earth? I mean, I missed
I
that bit.
can show
Like,
you again.
yeah, can you do
Yeah,
that,
so
please?
I'll open Google Earth again actually and show you real quick. That's a very good question. So let's go back to that same address, okay? 6546. Which way? So although this is not the same year, I'll open up the scale again, okay? So you go to scale, right? And then the scale thing pops up. Press R so that again it's like oriented in the north-south direction. And then now you pay attention to this, okay? So this, you see this length, right? And then you see these degrees. So you turn on mouse navigation, and what you do is you try to like stretch this line. And then
And keep the
if it's a
degrees at
long,
90.
exactly. Yeah, that's it.
Okay.
That's basically
Okay.
it. Okay.
Okay.
So yeah, then you take a screen grab. Anyway, so back to where we were. So what we did was we took this line segment, and then what we are going to do is we are going to measure it on the AutoCAD. So I go to this linear. Linear basically measures things in like the abscissa and the ordinate. So only the x-axis length and y-axis length are measured, right? So so here you go. So this edge, sorry, this end and this end, and then I put it somewhere here. So now, as you guys can read, this is 139 feet and 5/8 of an inch, right? Whereas in this, it is 440.57 feet. So I'll need to divide. Actually, I'll need to divide this quantity by this quantity to determine the scaling factor. Okay. So are you guys are familiar with scaling, right? Like what scaling is, or
Right.
scaling
Yeah.
factors are?
Yeah.
Yeah. So it's just the amount of times you zoom. So I have this pretty handy. It just like it's the format that the measurement is in AutoCAD. Otherwise, you have to like keep doing these brackets again. So it was 440.57. And then 139.05/8. So do you guys understand why we what this equation means, right? So this is 139 whole feet plus 0, and 5 divided by 8 is the fractional in inches, and that divided by 12 gives you this quantity in feet. Inches divided by 12 is the feet, right?
Mhm.
So because this was in feet, but this was in decimals, and this is in feet, but this is in fractions.
Right.
So so now we are going to calculate that. So we need to scale our image by 3.16839, this quantity. So what I do is I just copy this over, go back into my model, and then now AutoCAD has a scaling tool as well. So I will be using this. Now, before that, I just want to refresh like you guys' memory on AutoCAD. So in AutoCAD, the selection is a little like, weird, but it is also pretty helpful later on when you get good at it. So in AutoCAD, when you go, your cursor goes from left to right. It selects only the things that this rectangle completely covers. Okay, so you see that right now these two line segments, right? These were outside, the whole line segments were outside of this blue rectangle. So it did not really select that. They did not get highlighted with those little blue dots. But when you go from right to left, it selects everything that comes in contact with that green rectangle.
Okay.
Get it?
Got it.
So
Yeah.
yeah, so this is a pretty handy tool in AutoCAD, and once you get pretty intuitive, it works really fast. So anyway, so what I'm going to do here is I'm going to select this entire image and scale it by the scaling factor that we determined. To do that, I'm going to select this entire thing. As you see, all of even these lines are selected now, and even the image is selected. Then you see this scale over here. You go to scale, okay, and then you select some like a point near the base of this. So I usually select the left bottom corner, okay, click, and then here in the command window, it says specify the scale factor. Okay, so here I paste what I had from Google
The
Google
calculator.
calculation. Yeah. Oh, something went wrong. Yeah. So actually I did it correctly. So so now you can see that. So to make sure that you oh, actually one sec. Just give me one sec here. All right. So again, let me just do it again. So select this whole thing, go to scale, select this little place, go to the command window, press the selection. Sorry, paste the scaling factor. You see the scaling factor, and then press enter, and then it will scale. So you may see that this roughly scaled like 4 times, right? That was, or 3.18 times. That was our scaling factor. And to make sure you got everything right, this quantity should match this quantity, right? So now we are actually scaled. So 440.57 feet, 5.57 is roughly like 6 inches and something. So you see you're pretty much on the money.
Okay.
Now this was our house. So now we have sorry, hello.
Yeah.
Yep.
Okay, so now we have actually actually just give me one sec, guys. Someone is trying to call me. All right. Yeah. So now that we have actually scaled the image and got it in the right orientation, now is when we will start tracing the roof. Okay. So is everything clear so far?
Yep.
Yes, yes.
Okay, cool. So now I'm going to show you guys again how to start the tracing, and I'll also show you guys the user defined coordinate system, which I find pretty easy to work with. So sometimes the houses, as you can see, that I guess the longitudinal axis of this house is not exactly north south. It's a little like tilted northwest and southeast, right? So it's not so if I, let's say, like if I want to trace this rectangle, I could draw a rectangle, but then I'll have to like rotate it, right? So instead of that, what I'll do is I'll just rotate my orientation of my cursor, so everything is in this sort of I guess this sort of field, and then I don't really have to work hard on rotating things every time, because everything will be in relation to that orientation. Okay, so to do that, what you do is you go to the command window. This is the command window, by the way, this down here. And you type in UCS, that's a user defined coordinate system. You actually, before that, sorry, I forgot about that. So before that, what you need to do is you need to pick one of these edges which is the most clear, and you need to like trace it with a line segment. Okay, so you see this, like this roughly aligns with this side, right, this edge. So you kind of take a longer line segment to be more precise, and then you go UCS. That's, and then what this command then shows is what is the origin, or what is the orientation. So now what I'm going to do is I'm going to select object, and because I want to align everything to this object in the sense this line segment. So I go object, and then I select with that little square this line segment, and see this, the color of my cursor changed to this. And then I don't need this line anymore. So I select this and press delete to get rid of it. So now we are actually oriented with this house, right? So now we can actually start making the tracing the roof. So now now the layers start to become important. You have to make sure that this image is the image is actually fine. So anything in details layer is actually fine. And I don't know how much comfortable you guys are with layers, but layers basically are like just like layers in Photoshop. So they are, things can be in different layers, and then you can turn each and every layer on or off, or you can lock each layer. So do you guys get the general intuition of it, or are you guys like okay with that concept?
I'm good
I-
with layers, dude.
Huh?
I'm good with layers. I have like kind of stuff.
Okay.
Same, like I
Krishna?
have an intuitive idea.
Okay, cool, cool. So what we are going to, the reason why it's important is that we are going to put different things in different layers, as I said, and those are very important to us later on in a later stage.
I think, Rishi, if you could
So
give
the,
an example like of a couple of layers of what we are dealing in with
sure, yeah.
layers, that will give
So
clarity.
basically, I'll show you guys. So let's say like this is an object that I drew, right? I currently drew this in the details layer, the layer that the current drawing or whatever object is shown here. Okay. Now, if I want to change the layer of this, all I need to do is select this object and then go to this layers. All the layers will pull up, and then let's say I will go to let's say like property line. So now it has changed this layer. The reason why so I can't go much more in depth for this, and neither do I need to, because right now all we care about is that the things that I tell you guys to have in certain layers just need to be in those layers, and there are only 4 layers for me to work with.
Sure,
Please
sure.
just give me 1 second. Yeah? All right. So all right, so let's get back. So now for the rooftop, I will be using the rooftop layer, and there is this specific layer for rooftop. Okay. So now when we are doing the roof tracings, just the edges and all of these ridges and hips and valleys, we'll be putting them in rooftop layer. But layer is actually not the same as color and line type. Okay, so these are also important, but I'll show you the importance later. So now what I do is I'll go to the rooftop layer. Okay, and what I'll do is I'll start drafting now. And now this part is, there are like 100 ways to do that. Okay, so basically I'll do it my way, but you can actually do it in many ways. So some people like to trace these in them. There are some people like to use these things called polylines. There is no wrong, need to be comfortable doing this.
Uh, is it just me, or is Rishi's voice breaking for
It's
everyone?
mine too. Yeah, I think it's mine too. Yeah, keeps
or
breaking.
the
It's like
basic
lagging again.
layout of this roof is this, where
Rishi.
okay. Hear me? Hello.
Yep. Now it's better. We lost you for the last minute.
Okay. Okay. I can repeat. So so my point was that basically there are, can you guys hear me?
Yep.
Now it's better.
Okay. Okay. So my point was basically there are many ways to go about tracing this. Okay, the edges and all of these sort of details on the roof. and you can actually use all of these shapes, or you can use rectangles, or you can just even use lines in ortho mode, because what we have to keep in mind is that all of these angles, so you see these angles here, all of these will be either 90 or 45. Okay, so when you see from the top, typically in all American roofs, like houses, all the roofs have these angles, and they're usually 90 degrees or 45 degrees. Okay, so even in this house, you see this, the house on the right, this, you see this little isosceles triangle, this will always be 90-degree as the bigger angle, and the two other angles viewed from the top should look 45 degrees. Okay, um so so with that in mind, what we can do is we can basically start drafting in ortho mode, which saves all the angles as 90 degrees. So in ortho mode, you can only like move east or west or north or south depending on the coordinate system. So some people like to trace this in ortho mode, or I like to basically do rectangles, but there are many ways to do it. The important parts though are that all of these, typically all of these ridges, as you see these center lines, are typically in the middle of like the midpoint of these lines. So basically this will be in the midpoint of this line will be meeting at the midpoint of this. So there are only midpoints and 45-degree angles or 90-degree angles. Okay, so that is an important part. There are obvious exceptions. Sometimes you see that one side of the roof is like um like wider or longer than the, like for example in this house, this side is clearly like longer than or like wider than this, so this won't be at a midpoint. But typically speaking, even in this house, on this little dormer right here, everything like this line is will basically mean meet at the midpoint of this line. Is that clear?
Yep.
Okay. Anyway, so going back to our layout, so this is sort of the rough drawing that I'm doing, and at this point you can pretty much tell all the details from this Google image because it's good. But sometimes when the Google image is not that good, we do need the survey photos, and that's why I sent those survey photos. We have much higher resolution survey photos with taken by drone that we typically fly over these houses. And I'll pull up a survey photo that I actually sent you guys, and you'll see that there is much more detail in this, right? So let's just download this and try to work from this. The Google Earth image is pretty sufficient to figure out what the lines are, but it's not sufficient to figure out the details that are on the roof, like the vents and all. So that's why we need the survey photos. Anyway, so I'll show you guys one survey photo, and then we'll start doing the rest of the work.
Rishi, just a doubt. So, like,
Yeah, go ahead.
are we ignoring the lower part of the roof, like
No, we
the
will get
descending
to that.
part? Okay. Yeah.
This part, right?
Yep.
Yeah, we will get to that actually, but it's not as important, but because we never ever load panels on the lower side because it's covered with shadows.
Right.
So the main part is typically more important, and sometimes like you can get away with like sometimes the lower part isn't even visible to the whole extent, so you can get away with even like not drafting it a little bit.
Got it.
All right, so let me pull up an image right now. Okay, so you see this. This is like a little more clear. You see these angles, right? These will be all again always like 45 degrees. So this angle, if you go and measure from the top, it will be 45 degree, and these angles will be 90. And typically they always meet like that. And this image is high resolution. It's taken from a really good drone, so you can pretty much figure out what details are on the roof. So this is one kind of vent, this is another kind of vent, and so on. Anyway, so I like to have that image open. So I'll have it open on my, like I have actually two monitors, so I'll have it on the other side, but you guys can refer to that image that I have provided if you need to. But okay, so let's move ahead. Okay, so the outer edges of the roof, we will be drafting them um, in green. Okay, so in the rooftop layer, we will be selecting this by layer, and then all of these other properties will be by layer, and that means that it will be a solid line. Okay, now for the ridges, valleys, and hips, we will be using the same layer, the rooftop layer, but we will be using a different color, and we'll be using a different line type. Okay, so the color that we use for the rest of the details, or like the lines, is blue, and the type is hidden to. The color is blue, the type is hidden to. Again, I know that this seems like a lot to kind of take in at this moment, but I'm trust me, like once you guys do like 3 or 4 of these, things will be much faster and much smoother. So what I did here was, again, I am working in ortho mode. So I am going to draw a line up to here in the starting from the middle of this line segment. Okay, so to do that, actually, another, now I'm going to for a second, I'm going to tell you guys what these little things are in the. So these are basically object snaps. Okay, so this is to enable or like toggle ortho mode. This is to toggle tracking. So this basically you can set it to so that your cursor will only go in certain angles. This little white object here is the most important one. This is called object snap. So it automatically detects if it's the midpoint, if it's the like the one side, or if it's if it's like perpendicular, or if there is a circle, it sort of detects the center, and then it also detects intersections. Okay, so that is really important when drafting. So you have to go and right click here and make sure that all of um, these snaps are turned on, so they are like blue and highlighted. So typically we end up only using perpendicular, insertion, extension, intersection, center, midpoint, and endpoint. So that's why we don't have, like, that's pretty much all of them, but that's why we don't have all of them checked. So now going back, once I make sure that all of these snaps are on, I can pretty much select the line command and make a line at the center. Okay, so I know that this thing, which is called a ridge, extends until here. So I'll make a line until here, and then I'll press enter, so that line is there. Then I'll again select this line. For this part also, I'll make this ridge, again press enter, and same for the third one. Okay, and I'll extend it fast because later I can like trim these lines, but right now I'm extending because I'm going to have to make other lines here, and I want them to, I don't know exactly where they'll meet, so that's why I'm leaving some like extra there for me, okay, so that if it's short, then I don't have to extend it again. Then I go ahead and actually I'm going to try to make this part and this part. So I think Isaac wasn't here yesterday for this, but basically this part of the roof is called a hip. These parts and these parts of the roof are called valleys. And then these parts of the roof, these two and this large one, are called gable. Now I know that's really confusing. So for that, I'll actually pull up an image and share that with you guys. But before that, let me actually tell you guys how to rotate a line to align it 45 degrees from there. Okay. So what you do is that now I know that this valley is going to start from this corner on this house, right? On this corner on this roof. So I'll make a line here, and it's fine if I work in ortho mode and that line is perpendicular. And then can you guys like tell me how much this line needs to be rotated by so that it is like 45 degrees from here? Like will that be plus 45 or minus 45?
This will be plus 45, right?
Exactly, because we go the same way we go in a regular XY graph.
Right.
So plus 45, if I rotate, it will be counterclockwise. Now I know that since this is starting from this point, as I said, I had the object tracking on. Now to rotate things in AutoCAD, you have to first select them. Okay, so this line needs to be selected. Then you need to tell AutoCAD what you want to do with it. So you want to rotate it. Okay, then you go to the base at which you want to rotate it. You see that it asks you to specify the base point. So you grab this base point with your snapping, automatically that happens. And then it says in the command window, rotate, specify rotation angles. Okay, and the rotation angle we have as 45 degrees. Keep in mind that our model is already set to being in feet and 45 and degrees. Sometimes AutoCAD can be set to radians and inches or millimeters or even meters sometimes, but ours is set to feet and degrees. Okay, so we like if you the template doesn't really need to be changed anymore. So this is it. So I'm going to rotate it by 45 degrees. I'm going to type plus 45 and then rotate. So you see it rotated the line. Okay, now you see that this line is not meeting. So there are many ways to kind of extend that line. There is also, you can just like pull it in the extend with the extension snap on, and then it just extends. Or you could actually go ahead and select that line and like scale it. Okay, but that's just a simpler way. Now I know, again, as I said before, that this angle and like so basically like this angle will also be 90 degrees, because all of these angles are either 45 or 90, right? So two 45-degree angles will make this 90-degree angle. So what I'll try to do is I'll try to again make a line here and then make it like meet this line at 90 degrees. Okay. So one of the ways to do that again would be to make another like line in ortho mode. So this line is 90 degrees from this line. And then can you guys tell me now again how much I need to rotate this by?
Same again, 45.
Yeah.
Plus 45.
So same thing, select that line, rotate it by plus 45. So now I know it doesn't exactly align, but this much of I guess divergence from the image is fine by us. Okay, so that's not too much. This much roughly, that sort of area should remain pretty much the same. And then again, since this line is short, I'm going to extend it a little past 45 past that line. And then I repeat the same thing with on this side as well, right? So but now I know that this line is generally 45 degrees in terms of the entire model. So what I can do is I can just pick this line up from this point. So for that, what I can do is I can select the line, I can go to copy. Okay, so or again, AutoCAD first needs you to select the object, then give it the command about what you want to do with that object. And then once you click again, it actually follows through with that command. So I select this line, I go to copy, I select the base point, and then I copy that line in with reference to that base point, and I place it here. Okay. Is that kind of clear?
Yep.
Yeah, that's good.
Okay. Okay. And then again, I know that from here also I need to go 45 degree to roughly meet this here. Now it's the moment of truth. So either this will meet or this probably won't meet. So my money is that it will meet because it's pretty much a perfect geometry. But that actually it might not meet either, because it's, I guess this is like a longer side. So what do you guys think? If I push it there, do you think this a line from here to here will be 45 degrees or not?
Should meet.
Should be.
Everything else is 90 degrees rectangle.
Yeah.
All right, let's see. Okay, so we still don't know, but I'm going to scale this time by like 1.1 and drum roll. Yes, we did. So as you can see that all of these angles are indeed 45 degrees and 90 degrees, and this does like align perfectly, right? So although this doesn't align exactly with the roof per se, but it still aligns in our model, right? So, and that is sufficient by us, okay? And most of the times it will meet. So as a side note, for this little part also, like if you trace these two angles and then make two 45-degree angles from here, and then wherever they meet, take a line segment and extend it past, it will meet at the midpoint, okay? So now we are basically done with the top portion of the roof. The lower portion of the roof is also a similar process, but we can basically skip that. So because like I think I'm already like a little over time, and I want to sort of um, complete this before we go. So the next part is to sort of get rid of all of the unnecessary stuff that we have. Okay, so you see all of these like things that extend past. So to trim that, what you do is you select the entire model, then you go to the trim command. So again, you first select the object and then you tell AutoCAD what you want to do with that object. You select the entire model and then you go to the trim command, and the trim command basically trims line segments to the nearest point. Okay, so you see this part, this line segment, and these all of these line segments are selected right now. So the nearest point to this line segment is this point. So if I press trim here, or even if I select this, it's going to trim it up to here. Similarly for this, if I select this, it's going to trim it up to here. And I can also just select the object or click on the object, see? And similarly for this little body here. And then same on this side too, I just like get rid of these, okay? So now we have cleaned this up and we have basically all the lines on the roof. And now we are going to move to the next part, which is drawing the details, okay? Now for the details means the chimney, the obstructions, the little vents and all the little pipes that stick out of the roof, all the plumbing work. Sometimes it's just air conditioning work. Sometimes there are pipes. Sometimes there are like the TV dishes. So we need to actually get all of those in this layer called details, so that we positively identify them at the time of our our drawing, and later when we are trying to make the model, we have already accounted for their shade as well. Okay, so now you see that uh, these things, what these aren't isn't pretty clear, right? So for that you will need the drone image. So I can pull up the drone image again here, and then
Rishi,
I'll
I
brief.
had one
Yeah,
doubt. So when you're
yeah,
using
of
the
course. Sorry, go
extender,
ahead.
line extender,
Yeah.
so once you have it enabled in the object snap, do you also need to press any specific keys to use that, or it just automatically
No.
extends?
So basically, you know how even in like even in Apple, there is like that intuitive sort of UI that
Right.
basically like will snap it to extension. Like that, it will basically, if you try to extend it, pretty much does it by itself. So it's
Got it.
pretty
Got it.
smart actually. Okay. Yeah.
That's it. That's it.
Uh yeah. So moving on. So now I'm going to show you guys roughly what typically the obstructions are. So we don't really use, it's not that cold in San Diego, but people still have a fireplace. Okay. And these chimneys are typically extending out of the fireplace in their living room. Americans are kind of retarded that way. So you see this chimney needs to be drafted, because the chimney, like you see, if there is sun coming from the top, then you see this chimney, when the sun is in the east, it is going to basically cast a shadow in this part, right? So
Hmm.
you can't really put a panel here because it won't generate anything. So we have to make sure that we are clear from obstructions and we are away from these tall chimneys and trees when we are drafting. But um, most of the times we have, as I said, uh, we have the orientation of the panels given already in the survey sheet, so we don't really need to put our brains in it. But if sometimes in occasion, if it happens that the chimney is like, very close to a panel, then definitely that needs to be brought to attention. Anyway, so that's the chimney. It's a very common one. And then you see that there are these pipes. Okay, so there are two kinds of pipes that you might see right off the bat. So there are these pipes which look really thin. These pipes are almost like an inch in diameter, or like I think 1.5 inch, and roughly their entire area consumes around 2 inches, okay, in diameter. The special part about these is that you can actually mount the module on top of this. It doesn't matter, because these little and Rahul can probably back me up on this. These little pipes are just for that relief in our plumbing systems, so that the
Right. Yeah.
air that gets, yeah. So these can be went over, like you can actually put panels over these. We would prefer not to, because these still need to be rerouted a little bit. So we would prefer not to do that. But if there is not other space, it's okay to go over them. Okay. Then the second types of vents, the of obstructions that you see are these vents. Hey Rahul, what are these exactly called?
Those are attic vents or dormer vents. They
Yeah.
allow
So these are,
exchange of air in the
yeah.
attic.
Yeah. So attic is like, like near the roof there is usually
Mala.
space. Yeah. Mala. The
What's
third type
the
of
attic? What's the attic again?
so attic is now basically, you know how these houses have sloping roof, right? तो
Oh,
उसमें
got it.
but this inside they still have like flat ceiling. तो वो ceiling and वो roof
Roof.
के बीच का जो space है, that is
Got
the
it.
attic.
Got it. Got it.
Yeah, yeah. तो उसमें just like if there is like usually hot air rises to the top and it needs to be like cleared out of that. So these are typically kept on the top side of the slope.
Hmm.
Anyway, so these can't be went over. You have to like so if there is no space, then we have to like remove these and then put more tiles here and then mount over that. So if these are there, we try to avoid that. Then one more kind of pipes is again these pipes. I think these are also for the pressure relief, pressure related function, and sometimes, and these are almost like 2 to 3 inch in diameter. So we obviously can't go over this one or this one. Sometimes they are also for like some kind of like heat chimney that comes from the heater, not from the fireplace chimney. Okay. And then there are these types of ones. These are basically similar ones again to relieve the I guess vacuum or pressure. And these are basically pipes with this cap, like this, I guess, bent or C-shaped cap on top of them. Okay, so if you remove this rectangular cap, you'll still see like a circular pipe here. Okay, and I'll tell you, I have these symbols on how to actually like model these. Again, this is the smaller 1 inch diameter one. This can be went over. This is the larger 2 inch to 2.5 inch diameter, and this is the attic vent. All right, so now that we know what all of these obstructions are, we are going to try to approximately place them in our model. Okay, and to do that, we have already like defined these some symbols or I guess keys. So, and these are roughly 2 dimensions. So these are the ones that I showed you, that conical vent or um, attic vent. And then there are sometimes these low profile vents. These are not on this property, but if there is a chance, then I can probably show you guys later. So what we are going to do is we are going to either like copy these over to that, or we can honestly like we just like Rahul and I just like draw them on the go. So, but the symbols that we use are like this. So we saw that T vent, right, that I showed you with the cap. This for that we use this symbol. For the one smaller pipes with the 1 inch diameter, we use like a small like 1 inch diameter circle. Chimney, we use this, or or there is another one that I can show you guys later. Then the larger pipes, we use either like 3 inch or 6 inch and 8 inch, depending on the pipe. Sometimes there is also this thing called whirly bird vent. That those are the, you must have seen them on top of like factories where these metal objects just keep spinning. Um, and those also need to be, those are also for that exhaust, I think. So these ones, see.
Yep.
Anyway, so moving on. Now we are going to basically like get all of them using our AutoCAD. So okay, so now the second layer that we are going to use is the details layer. Okay, so we go to select that layer, we basically click layers, go to details, okay, the one with the red, and here again we're going to use by layer and again by layer. So both the color and the line type will be by layer. Sorry. Okay, so let's now model the chimney first. So to do that, what I did was I took this rectangle tool again. I made this approximate tracing of it, of where that chimney is. And basically what I'm going to do is I'm going to first trim this line, right? So as you can see, this line segment and this box, these meet at these 2 points. Now, if in that case, if we trim this, it takes that trim to the nearest 2 points. So if it's just like a standing, I guess, unattached line, then it will take the nearest 1 point. But if it is 2, then it will take the nearest 2 points. So if I press this, then it is going to get rid of this line segment between. Okay, so I'll press this and it is gone. Now to actually make another rectangle, I could either do just one more like rectangle like this, or I could do another thing called offset. So the offset tool is also really important in AutoCAD. Offset basically places a line or an object with a certain degree, certain sort of measurement that you specify. So again, to do offset, what you need to do is you need to first select the object that you want to offset. Now you go to offset command, you press again on the object. And for example, here I want to offset things by around 7 or 8 inches. So let me put in 8 inches in my command line. Everything in command line is always in inches unless specified by the either the single quote marks or the double quote marks. So single quote marks is feet and double quote marks is inches. So let's go 8 and then enter. So then it showed up with a 8 inch offset. I press OK. And then I'm just going to draw line segments from here to here and like that again. All right. And then now I'm going to do the attic vents. So I already had this little thing made here. As you might have guessed, to make this, you can use many tools. I basically used polyline. I can actually quickly show it on this too. I mean, approximately, it's not like it's okay. And then I'll make an arc like that, okay? So this is the object. Now what I'm going to do is instead of making like 3 or 4 of these, I have other options to work with here. So I know that this one is the same. So I'm going to select this and then copy it, okay? So I'm going to copy it, and to copy things, basically you have to select them and select the relative point from which you want to copy. So let's say like I want to copy it from here, right? So it's basically everything will be copied in this orientation. You see like this little gap between the vent and the ridge is going to stay the same. And then I paste it over here by again clicking it. Again, like, this thing seems a little complicated, but trust me, it's like super simple once you do it once or twice. And then I have another tool that is really handy, because now on this side, the orientation of this vent will change, right? So because here it was facing over this side, on here, this side, it will be facing over toward the western side. Okay, so instead of just like rotating it, what I can do is I can just mirror it with this center line. Okay, so I'll show you guys how to mirror things again. So basically you select them, you go to the mirror command. Okay, and then you select the line on which you want to mirror it by selecting the endpoints, and then again click and then press, you have to press enter. Okay, so that's how it mirrors things. And since I know that it has like moved a little bit, I'm going to actually move it back. And to move it, again, select it, move, and move it back. Okay. Yeah. So, and then I have like a couple of more obstructions, and I'll actually like just hurry up through them so that we can move to the next part. Okay. And
So Rishi, while you're doing
Why
that,
don't you just skip them?
yeah, go ahead.
yeah, I was asking like the option is always to just copy them from the legend and paste them, right? That's all. That's also an option.
Yeah, definitely. But the only problem is you'll have to rotate them again.
Got it.
So you'll have to, yeah. So I was trying to avoid that, but you definitely can paste them. And also sometimes what happens is that some are like big, small. So it depends. I mean, we don't really care what, like, these are not up to scale. These little things are not up to scale, but generally the entire layout is. Okay. Um, anyway, so let's just like get the other two. So I knew the two other obstructions here were this one over here. So I need to
Also, one
copy
more
this over
fundamental
again.
question.
Yeah.
If the drone image is so much more better than the Google Earth image and we can actually control it being completely orthogonal,
Yeah, why don't we just use it?
yeah, is it just because of scaling?
Rahul, do you want to take that? He knows much. Rahul is way more technically savvy than me.
Well, there isn't any real reason we don't use it. It's just one additional step because then you'll have to scale this image. And well, I guess the biggest contributing factor to why we don't select or use the drone image is because it's really difficult to align it north-south. And the reason we want to align it north-south is because we will be using the angle measurements, the roof angle measurements.
Oh, right.
Um,
And the sun's basically for your
right, right.
estimate for
Exactly.
your forecast, you'll need to know what is the
Exactly,
exact
exactly.
alignment. Makes sense. Makes
Yeah.
sense.
And
Yeah.
we have
And
to
then there is
meet
one. Yeah,
those
go ahead.
estimates
Yes. Makes sense.
because that's what we have promised the customers.
And then there is one more reason that so these cameras typically have a fisheye lens with a much shorter focal length than the satellite images. So the satellite images are actually like images almost taken approximately from infinity. So they are pretty much accurately flat. In these, there can still be some distortion, although it's pretty much under the acceptable like limits. It is. So sometimes if we don't find a good Google Earth image, we can actually use a drone image. And when we do that, we typically go to the drone image that's the most taken from the highest point. Like, so I'll show you actually all the drone images that we have. So you see, like, this is like as good as the zoomed in Google Maps image, right? So this is pretty much from a very high distance, and it looks
Yes.
pretty much the same as. So sometimes we do need to use that, and this is obviously like way better in resolution. Like you can zoom in and out, and you can see everything. We are looking at ways to actually like even get a better drone and so on, but that will take time.
Yes, it's just a
um
question that came to my mind,
yeah, yeah.
but it's answered.
um
Makes sense.
okay, okay. All right, so any questions so far?
Yeah, Adrian Isaac.
No, I'm good. I got it so
All right, yeah, sorry, I'm taking a little too long, but
far.
we
The
are like,
other bits, I think you can skip the little vents or whatever. I don't think we can figure that out.
yeah, exactly. So I'm going to like step to the next part. um so the next part is actually the fire clearances. Okay, and this is one of the most important parts, and for this part we need to understand what parts of the roof are, and I'll just like show you guys on Google Image again.
parts.
All right, so this is the typical anatomy of a, I guess, a standard roof. So you see over here, yeah. So you see that there are these parts that are also there on our roof, okay? So as you can now see, so yesterday, Krishna, you were asking, right, what is the difference between the angle from the top and the pitch? So the pitch is this angle. So the angle that the roof is sloping on, okay,
Right.
that we see from the ground. But these angles are always 45. This angle is usually like around 8 degrees to around 26, 28 degrees. That's when it's a really steep roof. Typically, it doesn't go more than that.
Got it.
Yeah. And then the other parts of the roof are the gable. The gable is what looks like this A, right? So this A thing is called a gable. You can see it pretty much in most houses. Then there is this thing called the ridge. Ridge is typically the center line. Okay, so the ridge is this part. Okay, um, and then there is this thing called valley. Valley is the concave sort of I guess liminal line between two sections of the roof. And there is the hip. Hip is the convex part. So the hip typically like protrudes, and valley typically goes in. So that's how it is. So you guys can look up more, but basically the reason why I'm telling you guys that is that the fire clearances from a hip and a valley are supposed to be 18 inches on both sides of the line. Okay, from the gable and the ridge, it needs to be 3 feet. So 3 feet from the gable and 3 feet on each side from the ridge. However, what we are basically trying to do here is we are going to project those 3 feet on a slope. So then it becomes, from when we see that from the top, when we see 3 feet projected from the top, it looks less than 3 feet. And the how much less it looks by is you can determine by multiplying 3 feet by the cosine of the pitch of the roof. Okay. So if that is really important. So if that is not clear, I definitely want you guys to stop me and ask me, is that fundamental clear?
I'm good.
Okay.
Adrian,
Isaac
Isaac.
and Adrian.
Yeah. Got an idea.
Okay.
Yeah,
Okay.
I'm good too.
Because
I think
because
all
we
three
are
of us
going.
have
Yeah.
gotten have done engineering graphics in first year, right?
Yeah.
That
Yeah.
hard
So
subject, yeah.
Yeah.
yeah. So now what is really important is that we are also going to use that same concept for our panel placement. Okay. So now what we are going to do is we are going to first draw the clearances. So to do that, we again use our old friend offset. Okay. So what we want to do is offset these lines. But since we can't directly offset these lines, we need to first put an invisible line on top of them. So to do that, what we do is we go to the invisible layer. Okay, there is a layer that is defined as in INV. We keep the same properties as the layer, and we trace out all of the gables, the ridges, the hips, and the valleys. Okay, so I'm going to do it fast because I've done it many times, but basically you have to trace all of these things out. Okay. So now I've traced all of these out. Now I'm going to define the offsets. So as I just mentioned, it is going to be an offset of 3 feet from the gable. So in this house, as you guys can see, if you view this house from the front and the back, these edges have that V, right? Sorry, that A section, right? So these three are the gables. Is that clear why?
Yes.
Which three? The
Okay,
one on the back.
I'll show you. So this
Right.
one in the back,
Hmm.
you see it's a part of an A, right?
Right.
This one in the front on the left side, and this one in the front on the right side. Okay, so I'll basically just show you what this house actually looks like in the front and the back.
The back one is pretty obvious, but the
You could
front
use
one.
street view.
Oh no, I have images. See?
Oh, okay, yeah, makes sense.
So yeah, so now it's much clearer. So
Yep.
this is an A, this is an A, and even you can see this part, right? So okay. So this one, and this one is a gable. Okay. Gables have how much? 3 feet unprojected, because we are not going to project it looking from the top. So again, if you guys need help with the offset tool, there are many tutorials, but it's really easy. You basically have to click the line and type in how much you want to offset that object by, and press enter, and then select the objects that you want to offset. No,
Why
it
don't you
sounds
turn the
pretty
image
weird.
layer off? It'll be easier
Sure,
to
I
see.
can do that.
And
Okay,
the reason
so
it's unprojected is because it's perpendicular to the slope. It's not along the slope.
Yeah.
If that makes sense. Can you imagine that?
Mm,
So if anything is along the slope, if you
right,
look at it
that
from the
has to be
top,
projected.
it has to be projected, right? And if it's perpendicular to the slope, in this case, it's going to be staying horizontal.
Right, right.
So you don't need to project it.
okay. So now I'm going to just turn the image off, and to do that, basically I select the image, and then this pops up. You just click show image, and then it disappears. Okay. So it's sometimes easier to work this way.
Yeah.
Now I know that the pitch of the roof is 22 degrees. How do I know that? It was roughly in the survey. Let's see what it is. Yeah, if it's not on the survey, it's there in the, we actually do the roof measurements. One sec. Okay, so see, these are the customer's roof measurements, and the one of our surveyors goes on top of the roof and puts this scale. So it's like 24.5. We'll round this down to 24 degrees, because we want to be conservative, and cosine of smaller angles is large. So that's why, that's like, to round it down is to be, it means to be conservative. Okay. So now what we are going to do is we are going to multiply 36 times cosine of 24 degrees. Now to make that handy, I actually have this one sheet that I go off. So I'll just put it up. So the pitch in degrees, and this is the ridge width. So this is at 24, it's 32.888. So we want to offset all of our ridges by 32.888 inches. So you again select the offset tool, go to the line, type in 32.888, press enter, and then offset it on the right, offset it on the left. Okay. Same with these two ridges. All right, and then to do that same thing, but with the valleys, now it is 18 inches, again unprojected. So go select them, go to 18 inches. Okay. All right, so now we have all of these offsets done, but as you can see, these are not really joined. So we're going to have to go ahead and join these all, and then trim the excess. So we again extend all of these lines.
Wait, I have a
Create
question.
this. Yeah, go ahead.
So when you drew the offsets for the ridges and the valleys, not the valleys and the hips, you said 18 inches unprojected, but you drew them as directly, with just 18 inches, but they are on a slope, no?
No, so Rahul, do you want to explain it again?
Well, this is kind of complicated because it's both changing slope and it's tilted too. So
do
the
we
math
not
will be
do
difficult.
the
Yeah,
so
so
do
we
we
just
not do the cosine, we just put 18 inches?
yeah.
Okay.
So like as a general rule of thumb, for only for the ridges we are using the projected scale, and for the gables and hips and valleys, we are just doing it
We are not.
unprojected, right?
Right,
Yeah.
right.
Right. So we'll just take that as a rule of thumb.
Mhm. All right, so I'm just gonna close these curves real quick, and then we can. So the reason I'm doing that is because I want to hatch these, right? So now you see like all of these are closed, and now I'll try to make this trim all of these lines to make this like a closed path. So one thing that is really important here is that you can't, sometimes there are these smaller artifacts that show up in AutoCAD and you don't want them. So we want to like steer clear of them. So we make sure to like, like even if there's sometimes like the line doesn't extend fully past, so sometimes it only extends like a little bit and it gets missed out when you're trimming things. So we want to like make sure that we are like double checking, triple checking for that. That actually our boss is a little bit of a stickler and he's a perfectionist. So he really doesn't like to see all of these things like not perfect.
Noted.
Trim this also. Okay, so once now you guys see that these are like pretty much like continuous figures, right? So now what I'll do is I'll basically remove the invisible lines from the on top of the original lines. Okay, so here we go, almost done. Okay, so select all of these and press delete, they disappear. Okay, so now we have these fire access pathways, but now there is one more step. We want to hatch them, we want to show them in red. To do that, we again go in our details layer, then go to hatch. Okay, and then by default it has select this ANSR 31 hatch, but we want to do it in solid hatch. So we go to solid, we select solid, and then we just like select all of these closed figures, press, and then it automatically like fills them up with the hatch. Okay, just so you know, it won't need to be changed, but the hatch transparency is actually set to 80. 80. I actually missed this one out. So is this generally clear? I can actually send you guys tutorials on hatching, but this is how we hatch things in general.
This
So now
seems
you
pretty
see that
straightforward.
yeah. So now you see we are pretty much towards the last step. Okay, so the last step now, one of the last important steps is to place the modules. Okay, so to do that, again we go back to our site survey. Okay, so site survey. One second. And just bear with me here. We're at the last 15 minutes at max. All right. So you see from here, we know that these modules are in like 4x2 I guess arrays, and they are on this like corner of this house. Okay, and to figure out what modules they are, they're like LG360 N1C N5 Australia modules. These modules have a particular size, and typically that size is given on this quick drafting reference sheet. This is 40 inches by 66.9 inches. So the length is for 66.9, width is 40. So what we want to do is we want to draw a rectangle of 40 inches by 66.9 inches and then project it on this 24-degree roof. Okay, so to do that, we typically use this geometric way. Yeah, you'd call it geometric, right, Rahul?
Yeah.
Okay, so
Graphical geometry.
Graphical, sure. So
One
what you
more
do
way to
is
do it would be just to like, because only one of the dimensions will be skewed, right? So we can just
exactly, yeah,
do that.
Yeah.
We can just use the cos of the angle and
100%.
Right.
So
Yeah.
our boss actually likes to see both the like so you see, if you skew it in landscape mode, like along the length, so you have to, the skew is along the length. But if you put it in portrait, sorry, I missed. Actually, I'll just show you guys. So see, you can put the panel either like, okay, if this is the roof, right? You can either put the panel like this, or you can put it like this, right?
Correct.
Yeah. So this is this is landscape, and this is portrait. Okay, these
Right.
are the two orientations here. But you see that in portrait, the longer length gets projected, and in landscape, the shorter length gets projected, right?
Correct.
This one is still on the same plane. So
Right.
that's why that's why we want to have one with, so in this 40 inches stays constant, and in this the 66.9 stays constant, right?
Right.
So that's why we want to have both of these in our at our disposal. So if we need to, then we can actually like arrange things
Yeah.
in portrait too. Anyway, so I'm going to go ahead and show you guys the graphical way, but there is also this cheat sheet, and I have already made these, all of these like modules. These are the most commonly used modules, and on the flat roof and all of these roof pitches, how much do the dimensions come out to be? I've already like jotted that down, so you guys can also potentially use that. Anyway, so um, a quick tip for rectangle is that even in rectangle, you can basically draw a rectangle given by the dimensions. So you go to the rectangle tool, click, then you trace, and then you press D, okay, dimensions, and then you press the two dimensions. So that I'll go 40 inches, enter, 66.9 inches, enter, and then you have to, this appears, and then you have to click again, okay? So this appeared. Okay, now there is another interesting thing. You need to copy this and rotate this to make it into landscape. Remember, this is still flat. We still haven't projected this. Now we're going to set up the rig to kind of project it. But before that, what we're going to do is we are going to put a distance or sort of gap between this panel and this panel. And that gap, we always have to be 3/8 of an inch. The reason why we have that gap is because that is where our sort of braces fit into those modules, and the thickness of those braces is 3/8 of an inch. So we have to, when we are modeling it, we have to keep like a 3/8 width between those two modules. Okay, so now AutoCAD has this thing where you can move things again in like a certain orientation. So I select this object, I click move, and I then go to this corner. Okay, I hover over this corner and then move my cursor up, so it gives me an extension. Now I type in the extension that I want to pick it up by, and this is going to be 3/8. Okay, 3/8 of an inch. I press enter. You see there is like this little gap between the crosshair and the model. Do you guys see it?
Right.
Yeah. Okay. So I put it here. So now this and this has a 3/8 gap. And then what I'm going to do is I'm going to make another line, like a straight line here. Okay. And I'm going to now copy this line. Now I'm going to rotate this line by minus 24 degrees. That's the pitch of the roof. Okay. Minus. So it shows up like this. Now I'm going to copy this line again. Okay. Rotate this by 90 degrees again. Okay. And then I'm going to move this here and then copy this over. Here. Okay. So now you see that this and this is like the cosine times of this, right? This
Right.
is like the projected length. So now what I do is I go to polyline and then I trace that rectangle here. So to do that, I press here at the intersection. I then hover over this line, press 40. Okay, enter. It basically puts a line 40 inches away. Then I go, snap it to the other four corners. So this is all going to come by practice, guys. You'll have to try out a couple of them, and only then you'll like see what basically I'm doing here. Okay, so and then again this, since the only the shorter edge changed here, this is going to be 66.9. Okay, so this is it. So now these two are the projected landscape and portrait of these two, right?
Correct.
This is in landscape. Now, can you guys tell me if, I think I already answered that, but if you remember, can you guys tell me if these are portrait or landscape? Oriented to the roof?
For the
Yeah.
roof, that's portrait, right?
Exactly, yeah. So
Because
is
the
everyone
long,
clear on that?
Yeah, I understand. It's based on where the ridge is, right?
Yeah.
basically the
So if
longer
I mean,
length is getting
you can look at
projected.
it in different ways. Okay, okay.
So that is why.
That's really important. Typically, I mean, you can also have like a mathematical rule that if the shorter edge is parallel to the ridge, then it's in portrait, and if the longer edge is parallel to the ridge, then it's in landscape, right? So that's also like a
Got it.
mathematical rule, but in general, it's pretty easy to identify if they're in portrait or landscape. It's like when you look at the roof from the ground, what does it look like? Does it look landscape or portrait? That's it. Anyway, so I'm going to copy these. So now we're going to use these projected ones, okay? And we're going to try to like orient them to our roof, okay? So I'm going to copy these over, and now I have to create this 4x2 array over here, right? So this is four modules by 2 modules, right? So I'm going to do that now. This is in, again, all of them portrait. So I can get rid of this landscape one for now. And then I'm going to have to rotate this one to make this edge parallel to this. Now, there are many ways to do that. So first, what you can do is you can basically rotate. This was rotated by minus 14 degrees. So you can now, 24 degrees. So now you can rotate it by plus 24 degrees. And then it is sort of rotated in the sort of perpendicular direction of our all of our axes. Then you can use the rotate tool, select this, go rotate, select any sort of corner, okay, and then it starts like rotating things using that corner, and then you can snap it perpendicular to this line, okay. So now at least this edge has become parallel to this edge, right?
Okay.
So now what we do is we simply need to rotate it again by 90 degrees.
90 degrees.
Okay. Yeah. Now again, I showed you how to offset things by a little bit. So I want to like create that 4x4 array. To do that, I'll select this again. I'll go to copy again. I'll select this corner. I'll hover over it, and then I'll hover a little above till that extension appears. Then I'll type 3x8, okay, and then go enter, and then I'll be placing it over this corner, and then doing it like 2 times again. Okay. So now I have this 4x1 array. Okay. So now I want to copy this whole array and place it here, right? So again, I select all of these. Now I'll be copying them from this edge. And again, we want to have 3x8 of an inch. And then select them and then put them here, okay? Now I have that my array. And now the last step is to simply just place it over here, okay? So now you see that if I place it over here, it is going to look like it's going to be going over the vent. In this case, typically we will place it as close as we can to the top of the house, because we want these panels as high as we can get to avoid any obstructions or any shadow, okay? So, and that's it, that is done. There are 2 more steps that are pretty like, like nothing scientific in that. So what you need to do is you also need to trace the driveway of the house. Then you need to trace the parcel of the house, okay? So those are 2 steps that you will need to do. So to trace the parcel of the house, what is a parcel of the house in America? Every plot of land has this unique number associated with it. It is called APN number. Okay, so that APN number is basically like the Aadhaar number of every house, and there is like a global information system database of that, and I'll send you guys the website of it. But basically, for now, I'll just show you guys real quick. So this is the website for the or the San Diego parcel lookup. Here I just type the address. Okay, so the address was, I think, 6546 Windward Ridge Drive. All right. So you see that this, when I typed it here, it basically took me to that parcel. And then when I zoomed in, it is basically, this is the house that we were working on. And then if you turn on the satellite mode, then you'll actually see the plot. Okay, so this is the plot. This is where it stretches up to. So it's pretty much what is visible, pretty clearly visible. But sometimes when these plots are remote, the lines or the compound walls are not visible. So you have to like refer to this. And again, I'll send this website so you guys can like refer to that. So for now, what I'll do is, since we don't need to be super precise, I'll just like trace it to this plot. Now, what is important is that we are going to select the property line layer, the prop line layer for that. Again, we are going to select blue, and then we are going to select Phantom 2 for our property line. I use a polyline. Polyline is a continuous line, and I roughly trace the parcel. Okay, so this is the parcel number. Okay, and then finally, I also need to trace the driveway. Okay, so the driveway of the house typically, so ideally I would have also like traced this house, but since we are just doing this part of the roof, but since we are only doing a tutorial, I'm going to skip that. But the driveway, if there was like, this was still an edge of the roof, then the driveway was just like this little part, right, where the cars drive, and the house has its garage over here, right? So what I'll do is I'll take the property line. This time I'll take the details layer again. You can also do it during the time you're carving all the other details. Go to by layer, and then just like draw this line here. And that's it. Okay, so actually there is, one more little step. In the survey sheet, what you'll see is there is this little blue colored dot on the house. So you see this little dot here. Everyone sees this, or like this little red rectangle over here.
Yep.
Red rectangle.
This little red rectangle. This is where the house ka service panel is. Okay, so service panel is where all the circuit breakers are located. So what I want you guys to do is, I want you guys to copy this service panel note from there. Copy it from this little like circle and place it where that rough orientation of that thing is. So it is like on this corner, right? So place it over here, and then orient that note so that it doesn't cross over the drawing. And it's pretty simple. Once you'll open this, you'll be able to easily figure it out. Okay. All right. And that was the very last step. Now only we need to change the fade on this image to 60. Okay. And then we need to put it on our site plan. So now you see that this model is complete. Okay. At this point, we are pretty much 99% done. From here, I want to make sure that my model is also on my drawing. For that, what I do is I go to this site 2.0. Okay. This is where things will be automatically filled in my drawing sheet through this thing called a viewport. Viewport is basically the area on the drawing sheet that kind of takes the view of a particular place in our model. Okay, so it's essentially like a wormhole to that place. And then I want to make sure that my scale is set to 1/16 of an inch is equal to 1 foot. Okay, so 1/16 of an inch on the paper is equal to 1 foot in the map. And then that is it. You guys need to save this layout at this point, name it with the customer's name, and then email it to me on the CAD. Okay, that we are at the very end of it, and thank you guys so much for sticking around. I know this took way longer than I actually anticipated.
Okay.
And yeah, if you guys have any questions at this point, I'll be happy to take them.
I think most of it is pretty clear, and once only we start
Yeah.
doing it,
When we
probably
try,
we could have
yeah.
a few questions.
Okay. Well, so do you guys think that you will be able to do this? I mean, this week maybe, or do you guys want to start with like doing one or two?
Actually, I'm pretty cool to do this
Yeah.
throughout
So I
next
think
week.
Huh?
for me and Ishaq, we have a busy week at work, so
Okay.
I think probably we can try a couple
Okay.
for this week, and then later on catch up. How
Cool.
do you want to
Yeah.
take it forward, Rishi? Like, what's the demand scenario right now?
Sorry, could you repeat that?
How do you want to take it forward? What's in your mind?
So, I mean, we have a lot of work, dude. So what I'm trying to do is I'm trying to get you guys started. This is one of the very easier ones, okay? And it took like 2 hours to demo because this, like, I was basically starting from scratch, but this actually takes me like 30 minutes to actually draft, okay?
Right.
So I'm hoping that you guys get started on this as soon as possible.
Yeah. So it's ASAP
At
for
least
you.
exactly. So
Yeah,
at
so
least
if
like
those two guys are busy, I am pretty free next weekend because like freelance stuff, and
okay.
I think I can take up some of it, and
All
I'll
right.
get back to you. Like we'll do it 1, 2, or 3, and then if you see if the holidays up to good, up to mark, then we can move ahead with
Yeah.
more. Yeah.
So so just one thing though, for communication, I think that we should like set up a, I don't know, what do you guys feel comfortable, like a WhatsApp group or email or something, because I'll have to, coordinate, and then if you guys have any questions, then I can, be available. Even Rahul and I both can be like available to answer that.
I think
So
the simplest is a WhatsApp group.
Yeah, I suppose.
okay, so let's do that. And
I'll make one.
okay, yeah, and thank you so much, guys, for sticking through the end. I know it's pretty intense, but trust me, it gets much easier.
No, you made it
Yeah,
seem pretty simple, Rishi.
Yeah.
I know. No, but I shit you not. Like you, once you start doing it, the third day you are like, dude, what the fuck are you doing this job, dude? Like this is bullshit. So yeah, I mean, it's so simple. So there is much more complicated work that we have, and obviously like bigger projects, bigger money. So once you guys are like trained fast, then we'll also be like open to sending that kind of work in you guys' way. So
Okay, so one
rest
question.
assured, we have a lot of work. Yeah, go ahead.
Like on a difficulty level, you said that this was one of the simplest ones, right? So
Yeah.
I just wanted to understand like what is the ratio of such drawings? Like if you have suppose
yeah,
say 20 proposals to make, what
yeah.
what proportion of it would fit into
Yeah.
a relatively closer
I'll tell
simplicity?
you. So it's not. So this is one of the simplest ones, and it is also one of the most common ones. Wouldn't you agree, Rahul? Maybe like one tiny skill level ahead of this, but it's pretty much simple because the basics here are this roof has all 4 types of orientation. So surfaces. It has a gable, it has a ridge, it has a hip, it has a valley, and that is it. So whenever there are those 4 things, it's like the simpler one. Sometimes there are like weird kinds of roof, people have like special kinds of tiles, they have special kinds of like all these custom things, and then they should start to get complicated. I'll just show you something real quick.
Yeah, just show me
So
a
there's one.
complicated one.
I'll show you one of the most complicated one that I have drafted. Okay, so there is this is actually a commercial project, and I won't open the PDF file, but I'll actually open the the sorry, I won't open the AutoCAD, I'll just open the PDF. Actually, this is what Rahul has drafted. Um, I have drafted this other one.
That's
This
even
is
worse.
actually, yeah, this is actually a commercial property. So let's see here. All right, so this is, you see, this is a commercial property, and this doesn't even have the modules. This just has the all the details. And this is like, you see, this is a car over here, and then these are all like HVAC units. Like this is the size of a car. So this is like in a much larger scale. And then once you add the modules here, then shit starts to become really whack. Like this is what my boss has drawn, and all of these need to be in a certain orientation. And then I'll show you what Rahul had actually drawn. So you see, this is Rahul's plan. So see, there are so many modules, and this. Okay, so one of the things that I haven't been over yet is how to make a scale model. Most of the times we don't need to make it, but I will actually, once you guys like get these basics, I'll also like send it that way, send that your way. But this is one of the more complicated ones, and then I'll show you one more. Just hold on. This was actually this one guy who's an early internet millionaire, and he has this fucking house with a nice like three swimming pools, two swimming pools, one whole
Oh,
stable, one tennis court. This is a fucking mansion. And see this roof, there are so many complicated parts on it. So
right.
this was my drawing, although my boss just scribbled his name on it. So that's how bosses work, but whatever. So I drafted this entire thing, and this, he's planning to fucking let it grow weed under this shit. Like this, he made this entire thing just to grow weed under that.
Whoa.
So yeah, can do. So
Cali. Time to come to Cali.
Cali Kush. Anyway, so yeah, so this was one of the more complicated ones.
Yeah.
This is like half of his property, dude. There was like a whole, like, you know, like he had like a fucking 6-horse stable in the thing. He had like a horse racing that little circle that they race horses in. So it's crazy. So there are these like massive projects too. Rahul had one which was like right on the cliffs, Sunset Cliffs karke, there is this place. So there are, you know, much more complicated ones, and our hope is that if we are able to like get you guys trained up at least on this to start with, and then later complicated ones, then we can be more free to work even on larger scale projects. Like this must be like a 20-30 kilowatt project. Like, you know, we want to hit like a megawatt project, or like, you know, 500 kilowatt project, like those levels. And that's where the actual money is. Then it becomes like utility or like infrastructure project, you know, so
Right.
public works project. Anyway, so those are, we have a lot of work, there is a lot of promise. And if you guys are interested, then I'll definitely be available to answer any questions. And if you want to get more work, I'll definitely be here to provide that. And yeah, rest of the details we can sort out with Krishna too. And
So
yeah, if you
like,
guys have any questions, then, yeah, go ahead.
no, like if there are any questions, let's address them first, and then we'll just conclude with the plan of action.
Could you repeat that? I lost you in the last part.
No, if there are any questions, let's address them first, and then we'll conclude with the plan of action. Like
Sure.
how we
Yeah,
want to
go ahead.
take
Go
things.
ahead.
I'm good. I'm good on
Yeah.
my end.
Also,
Okay.
like, we'll
All right.
also want to try out. Yeah.
Okay.
Isaac, Adrian, we good?
Yeah.
Yeah, I'm good. I'm good. I'm good.
Cool.
I just want to know how we're gonna get the work. I think it's through WhatsApp from now on.
Yeah.
Yeah.
So, Rishi, like, will you be sending more addresses as of now, or do you want to?
I'll send you addresses. Should I send you like right now? Right now, I can do that.
No, like, cause like it's weekend, so I mean, if
Yeah,
you
yeah.
have
I'll send it
addresses, I'd
over.
be willing to take them up. Yeah, cool.
I
If
mean,
you have like a list or
so
something that you just put up, and then we'll be like, I'll do this, and then we can just
exactly.
pick
So
up whatever you want.
actually, so let's start with that. So once we make a WhatsApp group, I'll start posting the you know, the addresses, the name of the customer, and then I'll also post the deadline. Okay, so the only two things in my expectation, I don't care how you guys want to do this, like, or split this, but the only two expectations that I have is that it has to be like, done by the deadline. And second
Got it.
is that it needs to be done in one go. So at first I'm completely fine. Like, you can ask me hundreds of questions in the first month, even if it takes like 5 attempts to get it right, that's fine. But we want to move towards that perfection, in which once we send it to you guys, we want it back perfect. Okay. And then
Okay, got it.
yeah, so those are the only two sort of expectations on my end.
Krishna, can you share the whole call that you recorded? No, you can put it on
Yeah,
Drive or
yeah.
something.
I'll
Okay.
get the link
Yeah.
to it. I'll share the link.
Fine, that's
Yeah. All right. Yeah. Thank you so much, Krishna, for coordinating this too. I really appreciate that. And
No
thank you so
issues.
much, guys, for showing up.
Okay, all right. I
Okay.
think
All right.
Okay, I think we can conclude and say
Yeah.
bye-bye.
yeah. Say bye.
Yeah. All right, guys. Hopefully talk soon again.
Yeah.
Yes, yes.
All right.
See you guys.
Okay, bye bye.
Bye bye.
Bye.